16, 3 squared would become 9.
Okay.
But I have a feeling that's wrong.
Not that it's wrong. It's not wrong.
It's just not the right step to take first.
Because
Would I possibly multiply the 3 to the x and the 3 squared? So then would it be 3 to the power of x plus 2?
Okay, yeah. So you can simplify
Yeah?
that. That's 3 to the power of x plus 2. Equal to
4 squared or 16? Would I leave it as squared? Yeah. What now?
What now?
I don't know.
Okay. So instinctively, do you have any idea what you do next?
Nope.
Nope. All right. So based on how this is, there's not much you can do right now. But if I had a 3 here, if I had another 3 here, what would you do?
What would I do?
Yeah.
There was a 3 on each side.
Yeah. But you're solving for x. Hold on. Oh. Just give me a break here. I had something planned for you, that's all.
Oh, today at Staples, I got purple lined paper.
Purple lined paper. They
Yes,
ran out of other colors?
No, I just saw the purple and I thought it was fun looking.
Okay. 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 Nice. Nice. Nice, Sophie. Nice. Nice. All right. So here goes your next one. This holiday has just slowed up.
I wouldn't call this a holiday.
Is it?
Yeah.
What is it?
A pandemic?
Sophie,
That's what it is.
Go away. This is a holiday caused by a pandemic. Do you have a calculator?
Yes. Six.
Log x to the 64. Da, 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 da. Okay, Sophie. Here goes the question. But before we go to the question, let's look at a concept. Okay. Now logs is basically the opposite of you doing anything you're doing with your exponent. Okay. So let's say, and before we do this question, let's say we have the expression 5 squared. 5 squared is equal to what number again?
25.
5. Okay. Now, what logs do is log enables you to go in the opposite direction. So let us say you want to say, what number do you raise to what power to get 25? Okay. So in other words, again, we got 5 squared equal 25. Well, 5 raised to what power gave you 25? So that's what logs can do for you. I know this one is easy, but what you're gonna do for me is I hope we can figure this out in the calculator. There is do you see the log button on your calculator?
Yes, bottom left.
This might take some time. Number 1, we're starting number 1.
1a is 1 over 0.17.
How did you get 0.17?
Because I did sine of 170.1 and then I put it over 1. I found the reciprocal.
You put it over 1 or you put it under 1?
Under 1.
Okay. All right. Next one.
And I did the same for the others, but with their corresponding whatevers.
Yeah.
So don't ask for me to explain it again. B is 1 over 0.096.
Okay.
And C is 1 over 0.99.
What did you use for pi?
A pi button.
Really?
Yes.
That will put you in the radians, I believe.
Pardon?
That will put you in radians mode, a different mode. That's for grade 12 math.
Okay.
You're to put 7 times 180.
Okay.
Because pi is 180 degrees.
Well, I didn't know that.
Oh, really? Yeah, because the whole circle, pi has a value of 3.14, but in the whole circle, halfway through is pi. Okay? So from here to here, that's pi. Okay? From there all the way around here, that's another pi. So that's why the circumference is 2 pi, which is the same as 360 degrees. Okay?
Well, I didn't use that for my other pies.
I know. So
expect a lot of wrong answers.
Unless your calculator is working the right way. Could you just try it and see first?
Try
7 times 7 pi, but use pi has 180.
21.99.
7 times 180, you get 21.
7 times 180, I get 1,260.
Divide by 4.
315.
That's what you're finding the cut off.
Okay.
That's the angle.
Okay.
See if you get the same answer as when you put pi in the calculator. If your calculator is in degree mode, it should give you the right answer. If it's not, it will give you the wrong answer. It will take pi to be 3.14. And that's why you got 21.
Okay. Is the answer 1 over -1?
1 over what?
-1.
You mean you have 1 over
-1.
This is what? Cot?
Cot.
Is 1 over tan, which is...
Tan gave me -1.
So tan of 315.
315.
Yeah, I gave you what?
-1.
Okay, so it's 1 over -1, which is -1. Yep, next one. And then you just do the same story for the next one, right?
Do I have to redo it?
No, you're not dumb. You're not that dumb. Sorry. Did you hear me just
Well,
now?
my wrong answer for the next one is 1 over 0.99.
But you know to correct yourself now.
Yes.
Okay. So let's go on. Let's go to number 2.
2. Cos of theta is 5 over 13. Sine of theta is 0.0067. Cusc of theta is 1 over 0.0067. Tan of theta is 2.39998. And cot of theta is 1 over 2.339998.
Hold on. Make a diagram and find the other fives. What's the diagram look like? So here's a triangle I drew for you.
Yes.
Yeah, what would we put there? Can you go ahead? I'm giving you control of my screen, and you go ahead and
You
draw.
want me to put angles in?
Label. It says make a diagram and find the other 5 ratios.
I did make a diagram. Do you want to see my beautiful diagram?
Not from there. Draw it on the screen. That's why we have this here. Draw it. Let me see. I drew the triangle for you already.
Hmm.
Let me give you a brighter color. Hold on.
How do I write?
You're drawing right now.
Ah.
Let me give you a brighter color.
But why is it so delayed?
Let me give you a brighter color. Hold on. Red. Hold on. Erase. You really want these in there?
Can I just tell you what the 2 angles are?
No, you're to I want to see the label diagram. That's what's important first step.
Can I draw?
Oh yeah, go ahead.
I can't now. Oh wait, now I can.
Yes, you can.
Goodness, I don't like drawing on my laptop. Wait, no, I wrote the wrong number. It's 67. How do I undo?
You're not. I'm not asking. You said the question, Abby. Let me see, Abby. Sophie.
That's
Sophie,
wrong.
Let me erase it for you.
Yeah.
Hold on. Let go. Okay. Erased. Sophie, you're to label your triangle. So
I'm labeling.
No, this is theta.
Okay.
So how based on the information you have here, sec theta equals 13 over 5. How do you represent that on this diagram?
I don't know.
Oh, I thought you got it. You have to now translate what you have. Sec is what? 1 over cos, right?
Yes.
Okay. So this is 1 over cos.
Mm-hmm.
So this is 1 over cos. Sec. We have 1 over. Hey, there you go. So how does this 13 over 5 get represented? Let's think about that.
I don't know.
It's 1 over cos. So it's supposed to be 1 over x.
Mm-hmm.
Okay. Yep. So it says sec of theta is equal to 13 over 5. And sec, so in other words, sec theta is equal to 1 over cos is equal to 13 over 5.
Mm-hmm.
So how do we need to put this on the diagram. We need to represent each part, Sophie. So let's also think with me here.
Okay.
Each part needs to go on the diagram. So what will be the hypotenuse? What will be everything?
I need to draw the hypotenuse.
You need to put in the measurement for the hypotenuse, etc., etc.
Well, I'm not doing it on that triangle because that is hard to work with.
All right, do it in front of you and I'll do it on this for you.
So I know it's a right angle triangle. I put my bottom angle as 67.38. And my upper angle as 22.62. Now I need to find side lengths. Why am I forgetting how to find side lengths?
I don't know.
I don't know either. I don't know. Yeah, I don't know.
Oh. Yep, just keep trying, keep trying. What did you get as the answer?
What was the answer for what?
For number 2, in terms of the other 5 ratios.
Cos was 5/13. Sine was 0.0067.
Which is what?
I don't know.
How did you get cos to be 5/13?
By flipping.
Flipping what?
By finding the reciprocal of the sec.
Okay, so you flip it over. Okay. All right, so you start from there. So you say cos is 5/13.
Yes.
Okay.
No, sec is. Oh wait, yeah, cos is 5/13.
So you say okay, so good. So cos is 5/13. So if you were to label your triangle, so look at your triangle now. If this is theta, use that. If this is theta, and cos is 5/13, that is correct. Then cos is equal to what? Adjacent to the hypotenuse, right? So this has to be 5, and this has to be 13, correct?
Yes.
And that's how you label a triangle.
Okay.
Okay. Now, you could have used sec because remember, 13/5 is the same as 1/5 times 13, correct? So, in other words, you could say 13 is your hypotenuse. On that one, okay? Got that? All right, so go ahead and what about sine? What's sine equal to?
Oh, I'm just finding the other side length.
Oh, you didn't find?
It's 12.
12. Okay, good. So sine is equal to what? 12/13, right? Good. Next one.
Yeah.
Yeah.
Kusk. Is that the next one?
What's tan? What's tan? Tell me what's tan. What's tan?
Tangent. Ka. Adjacent over hypotenuse.
What's the answer for that one?
5/13.
Okay.
Wait, no.
No, 12/5. 12/5.
Yeah.
Tan is 12/5. Because this is 12, right? It's 12/5.
It's just my triangle's like opposite to yours. It's a mirror image, so it's just.
Okay. All right, next one.
Tan. Adjacent over hypotenuse.
We just said that, 12/5.
Yes. Oh wait, cot. 1/tan.
Yep. So that's what?
1/2.39998.
But tan is what? Isn't tan x over y?
Pardon?
Isn't tan x over y?
Yes.
So that's 1/5/12 over 13, right? No, 5 over x over y over 12. Hold on, what am I saying?
I don't know. I don't know where you're going with this.
Okay, so let me go again. That's cos.
Wait.
Sine. So it's 1/.
What was tan again? Because don't you just flip it? Because isn't it just the reciprocal?
Yeah. Oh, you did tan.
Yes.
Yeah. So tan is 12 over 5.
Yes.
So cot is 5 over 12.
Yes.
Yeah, that's it.
Yes.
But I'm trying to work it out. So if it's 1 over tan, and so tan is 5 over 12, right?
Mm-hmm.
No, tan is 12 over 5
Mm-hmm.
because tan is so ka adjacent over hypotenuse,
Mm-hmm.
op- opposite so ka toa opposite over adjacent. So that's 1 over 12 over 5, right? Using the properties of division, dividing by that, 1 divided by 12 over 5 is the same as 1 times 5 over 12, right?
Mm-hmm.
To keep it multiply. That's why it worked with the 5 over 12. Okay? Cool?
Cool.
Next one. Last one.
Last one.
CSEC.
The kusk.
Yeah, that one.
So I got my answers as 135 and 225.
135 and 225? What the heck is that? Those are the
Find
angles?
all possible values.
Oh, you didn't do the last one. CSEC. What's CSEC? CSC.
Kusk.
Yeah, did you do that one?
Yeah, number 5, my final answer is 135 and 225.
Okay, how did you get that?
So basically, what I believe I did not write down all my work, which kind of sucks.
What you believe you did.
What I think I did, what I would do now. So I know that the sine of my angle is going to be 1 over the negative root 2. So then what I probably did is I probably inversed that, which then gave me negative 45. And then I went around to that 360 thing, like 180 minus theta, 180 plus theta, 360 minus theta.
Okay.
I found my notes from last week.
All right.
I found the 2 valid answers that were within the 0 to 360.
So you use sine, you said? So sine?
Yes.
So you use sine of theta equal to sine is what again? Opposite over hypotenuse. 12 over 13?
Oh wait, what number are we doing? I'm doing number 5.
What? We're not done with number. I'm finishing number 2.
Oh.
Uh-oh.
Oh, wait, what question are we on?
Number 2, Sophie, number 2.
Number 2 still?
Yeah, he's not done. It says determine the possible values of theta.
Oh.
Oh.
Okay.
Yeah. So go ahead. So
Sine.
I was saying sine of you. You can use any one of the ratios because any ratio should give you the same answer. Okay.
Okay.
So if you use sine of theta equal 12 over what? 13.
It's gonna be
Sine inverse of that, right?
Yeah, 13.
So we're gonna find theta, right?
Yes.
Which is sine inverse of that.
Mm-hmm.
Work it out.
67.38. Right?
Okay. Yeah. And then
Wait,
what?
let me double check that because that was like my original work and I'm not very trustful of that now. I was right.
67 point what?
0.38.
Okay. So 67 degrees.
Yes.
So and how do we find the other solution? How many other solutions are there, by the way?
4?
Really?
Oh.
Nope. You have to check.
2.
It's 2 because it says sine theta is a positive 12 over 13. So you have to find where the sine is positive, and it's only in 2 quadrants. Which 2 quadrants are those?
The top 2.
Which 2? Quadrant 1, 2, 3, 4, 5, or 10?
Or 10.
Joking, Sophie.
So 180 minus that works. 180 plus that works. 360 minus that works, right?
You're saying that there's a solution in all quadrants?
Yes.
Okay. Okay.
Okay.
Okay. So what are the answers?
You want me to do it?
Yeah. Anyway, don't do it. Next question. Number two.
Number,
Number three.
number 3. What did I do for number 3? Oh, I did it on a piece of paper. Where did my paper go? Here's my paper.
I know.
Yeah. So I inverse tanned root 21 over 2, which gave me 66.421. So tan of theta is root 21 over 2. Cos of theta is 0.4. Sec of theta is 1 over 0.4.
You know that, no, hold on. Nobody want those angles. No, those decimals. Exact values. You see that part of the question? Look here. Find the what? Look at that. You see
I thought
that
it was
one
like
there?
0.41 or something.
You see that? You see that one, Sophie? Find the exact value.
So
Exact
you want
value.
some stupid fraction?
There you go. I know you love the beautiful. Let me say it again. I know you love the beautiful decimals. But I'm sorry. Exact values only. Thank you.
It's a little late for that. It's fine. I'll take my 0.4.
Nope.
Sine of theta is 0.9165.
Unacceptable.
Of theta is 1 over 0.9165.
Unacceptable.
I care to disagree.
Unacceptable, Sophie. Let's go. Let's go. Let's go. Let's go. Do the right thing.
Okay, cos of my answer is 0.4000131412.
Sophie, exact value, which means, remember we started this one? I drew the triangle. You
Yes.
translate all of what you started with into your triangle. Okay? So translate this here. Cot. This is cot, right? Which is tan, right?
Cos, yes.
So it's 1 over tan. So this is the same as what? It's cot of 2 over 21.
Yes.
Yep, so
Cos of 2 over 21?
Yep. So this is x. So what's at the top is x, and what's at
That
the
does
bottom?
not give me the same thing.
Hold on. Isn't 2x, which is cos?
What?
Okay, tan. This is a tan function, cotangent, right?
Yes.
This is basically 1 over tan, right?
Mm-hmm.
Okay. So translate this into this here. Translate that.
Tan is root 21 over 2.
Tan is what?
Root 21 over 2.
So tan is root 21 over 2. Okay.
Yes.
So start from there. So tan is equal to, tan of theta is equal to root 21
over 2.
That is perfectly correct. Now use that to fill in your triangle, and then you can get it from there. So what is the root 21 equal to? Opposite or adjacent?
Ta.
Toa.
Toa.
Toa. So that's that.
T-O-A.
That's
So
that, right?
it's opposite over adjacent.
So that's
Yeah.
that, and this is 2, right? Okay, so then you can figure out everything else from there.
Yes.
Go ahead.
I'm going to draw this out.
For sure. Go ahead and draw it out.
Am I in my right mind?
I don't know.
Inverse tan root 21 over 2 to get theta?
You're going to inverse tan?
Yes.
Yeah.
To get my angle? Yeah.
Yeah. If you want an angle. But do you want an angle right now? Or you're trying to find
Yes,
the other
because then I can just use the angle for everything.
Okay. But you want to you have to find all the ratios, right? So you have tan right now. You need to find sine, cos, c sec, and sec. So you need all those ratios too. So let's talk about sine. Let's do sine now. What's sine?
So opposite over hypotenuse.
So, and that's what? Do you know the hypotenuse?
No.
Okay, so how are we gonna get the hypotenuse?
Pythagorean theorem?
Pythagorean theorem or trig ratios?
Pythagorean theorem.
Okay, that works. Anyone work? You have
It's
two.
5.
It's what?
5.
5?
5.
Okay. So therefore sine is what? 5 over 21?
Mm-hmm.
I mean
No.
root 21 over 5?
Mm-hmm.
Yeah.
Yeah,
Correct?
and then yes, and then kusk would be the opposite of that. It would be inversed, so it would be 5 over root 21.
By the way, Sophie, you know that this is a negative 2? It doesn't matter. Just keep working.
I don't see that.
It doesn't matter. Just keep working. Sorry, because you don't see. That's why. Just keep working. It's difficult to see it, right? But go ahead.
Yeah, that does not look like it to me. So I'm. Mm-hmm.
So that's 5. Okay.
Yes.
So sine is equal to sine of theta is equal to what? Root 21 over 5.
Yes, and then cos. Let's do cosine.
Mm-hmm.
So ka. A over h. Adjacent over hypotenuse. 2 over 5.
2 over 5.
2 over 5.
What?
Over 5.
Cos.
Cos. So ka.
Yeah,
Adjacent over hypotenuse.
Yeah, cos 2 over 5.
Yes.
Yes.
Why are you questioning?
By the way, could we have gone a different route to find 5 as the answer? Could we have used a trig ratio? A certain trig ratio?
Yes.
Okay. All right. Carry on.
Yes, but yeah, I've got all of them.
All right. Good.
In fractions.
Did you do c-sec and sec-cat? Nope.
Yes, I did.
What's c-sec?
5 over root 21.
Okay. All right. Next, move on. Let's go.
4.
Let's go to 4.
Remember how all my answers were wrong?
Fix them. Fix the first.
You want to hear my wrong answers? I can just calculate them and tell you as I go. First one is 0.
What, sine of pi?
Yeah, sine of 180.
Mm-hmm.
Second one is negative 0.866025438.
They said exact value. Did you pay attention to that information?
Yes.
Okay. So if you did, then please proceed. Be careful. If it's not the exact value, your answer is wrong. Wrong.
My next one is negative 1.
Which one is the next one?
C.
Did you tell me B already?
Yes, I did.
What's B?
I don't know. It's past my calculator. I didn't write it.
If you're giving me a decimal answer, unacceptable.
Okay.
So you got 7 times pi divided by 6. What did you get when you did that part?
7 times 180 divided by 6 gives me 210.
210? So you're doing the cos of 210?
Which is not a friendly number.
And this is where you use a unit circle now, okay? Just to tell you, this would be a root 3 over 2.
Mm-hmm.
That's the same as root 3 over 2. The answer is same as root 3 over 2. Okay? That would be equivalent to, look at where half is, where cos is a half. By the way, unit circle.
That's an oval.
Oh, yeah.
It's an egg.
An egg.
The unit egg.
Yep. On your unit circle, or your unit egg, according to you, that, and at our 2, what did you get a while ago? 210?
Yes.
So there's an equivalent angle to 210, which actually gives you the same thing as half, which is root 3 over 2. Okay.
Okay.
So let me, if I bring up when we're done, I'll bring up another unit circle so you can see it, okay?
Okay.
But you'd be expected to actually use memory here. So the cost of this is going to be equal to root 3 over 2.
Mm-hmm.
And if you put root 3 over 2 in your calculator, you will see you get the same thing.
Mm-hmm.
Okay?
Mm-hmm.
Can you divide root 3 by 2 and see if you get the same 0.7, blah, blah, blah?
I get the same but positive.
Because this is positive root 3 over 2.
The other one gave me negative.
Okay, so this is negative root 3 over 2. Because it's down here, right? It'll be down
Yeah.
here, right? So if it's down here, it's 210, then it should be, the angle is somewhere down here, right?
Mm-hmm.
Which is negative anyway. Yep.
Yeah. Can we move on to the next question?
Yeah, for sure. E?
Can we do 5?
05? Yeah.
Yeah. I got 135 and 225.
135 and 225.
Yes. Find
What?
all possible values. Those are
You
the
said,
2 possible values.
you said 135
Yes.
and 225?
Yes.
How?
How? Okay. So basically what I figured is because the kisk
The C-sec. Say C-sec.
the kisk is the sine one, right?
Mm-hmm.
Yes. So I figured that sine of that of theta is going to be 1 over negative root 2.
Mm-hmm.
So I inverse sined that, which gave me negative 45.
All right, hold on. Slow. You lost me. Go again.
From the beginning.
Yep.
Okay, because the kisk of theta is negative root 2, I figure the sine of theta has to be 1 over negative root 2, or negative 1 over root 2.
So you're saying the sine of this
Yes.
is you're going to inverse this.
I'm going to invert. We're on number 5, right? Just.
Yeah, number 5.
Okay. Yes, I'm going to
So
inverse
so this is
sine.
you're saying this is 1 over negative root 2?
Yes.
Okay.
And then I inverse signed that
Mm-hmm.
to find my angle,
Mm-hmm. And what did you get?
negative 45.
Mm-hmm. And then?
I went around the unit circle finding the possible values,
Yep.
which gave me 135 and 225.
So you get 135
Yes,
and what?
225.
Okay. How did you come to get these answers?
So I believe it fits into the 2 left quadrants.
Which quadrants are those? Number them. They have number identity.
2 and 3.
So you're saying
Right?
sine is negative in quadrant what?
I don't know what the quadrants are.
Quadrant 3 and 4.
How does the counting work?
We went through this, Sophie.
Yes, I know, but I don't remember.
Because you didn't want to remember.
Yes.
Because you told yourself you didn't want to remember.
Yes.
I know.
I know too.
And now it's coming to haunt you like a ghost. Casper.
It can haunt me in grade 12. I could care less.
That's quadrant 1. Anticlockwise. 2. 3.
I believe it fits into quadrant 2 and 3.
Sophie. Sine is negative. This is negative. Isn't that sine theta of negative 1 over root that? Root negative 2? So it's where sine is negative.
45.
Where is sine negative? Isn't it quadrant 3 and 4? Hello?
Yes.
Sine is negative in these two quadrants, right?
Yes, but it didn't work in the quadrant.
What?
Yes, but if I was to take the angle that I got,
Yeah.
which was negative 45, and 360 minus negative 45 does not fit within the bounds that I was given.
What's the answer? What do you get as the answer?
I got 225 and 135
No, I'm saying
in quadrant 2 and 3.
but quadrant 2 is not a solution because the sign has to be
I
negative.
feel like this is the same problem we encountered last week, where because it's a negative angle, it's not starting in quadrant 1.
Okay, you got 45 when you did it, right? Correct?
Negative 45.
Okay, so negative 45, forget about that. It's 45. Okay? So, yep.
So you are dismissing my answers?
No, it's the same story. 45, okay? But then it says you have to follow the concept now.
Well, if it was positive 45, then that first answer would be a possible value.
No. Which one?
45.
No.
If it was a positive 45, then my answers would be in quadrant 1 and quadrant 2.
All right, fine. But that's not the case. The angle is you got negative 45 as the answer. Yep. Okay. But we're saying that there are no such thing as negative angles, correct?
Sure.
That's the same. Yeah, it is the same situation we encountered last time. So there's no such thing as a negative angle, and that's a fact. All right. So we just assume that the angle is 45, but that's not what your solution is. Your solution now is wherever sine theta is a negative value. Okay? Because this is actually negative 1 over 2 over root 2, or 1 over negative root 2. Okay? So you want to find where sine is a negative. 3 and 4. Is that clear?
Sure.
Clear?
Sure.
So here you know it's going to be what? 45, 180 plus 45?
Mm-hmm.
That's going to be 180 plus 45. What do we get there? What? I know you got 225, right?
225.
And then the other solution will be 360 minus 45.
315.
That's your answer. You have to pay attention to this value. It says sine of theta is a negative. So you have to find in which quadrants is sine of theta a negative. And that's where you'll find your solutions. You want to check if it's correct? You can go ahead and punch it in. Go ahead.
No, I'm good.
Punch 315. Punch 315 in.
Yeah, that's right.
Okay. All right, Sophie. See how it works out? So ignore that negative 45. It's just a reference angle, okay? It's one of the reference angles, but it's not a part of your solution. All right? Because it gives you a negative 45, but forget about it. Just know that an angle must be positive, okay? An angle cannot be negative, but the 45 is not necessarily a part of your solution set. Okay?
Okay.
All right. So those are that's. But when you tried 135, did 135 come out right?
It came out positive, but the same number.
No, but if it came out positive, it's not correct. Can it be? Hello. If you got a positive, can it be correct?
No.
No. So you see the point? Because it says sine of theta has to be a negative value, which is 1 over negative root 2, or negative 1 over root 2. Okay?
Okay.
All right. So what we'll do when we meet next time, I'll prepare for that unit that you're working on right now. Okay?